Chapter 4 is all about performance optimization, and this is where you go from understanding iceberg to mastering it. We'll cover compaction, sorting, Z-ordering, partitioning, and the copy-on-write versus merge-on-read trade-off. A common issue in data lakes is the small files problem, where streaming writes and small inserts create thousands of tiny files. This hurts performance because the system spends more time opening files and reading metadata than processing data. Compaction fixes this by merging small files into larger ones. BinPack simply combines files without changing order, making it fast but not improving layout. Sort compaction also orders data by a key column, improving pruning since each file covers a tighter range, e.g., dates. Z-order compaction is more advanced, clustering data across multiple columns so queries filtering on different combinations can skip more files. Use BinPack for quick cleanup, sort when one filter column dominates, and Z-order when queries span multiple columns. Now the big trade-off talk, copy-on-write versus merge-on-read, which defines how updates and deletes are handled. With copy-on-write, any change rewrites the entire data file containing the affected row. Updating a single row in a 100 megabytes file rewrites all 100 megabytes. Reads are fast because no reconciliation is needed, but writes are expensive. With merge-on-read, changes are stored as small delete files, while the original data files remain unchanged. During reads, the engine merges deletes with data to produce the final result. Writes are fast, but reads do extra work. In practice, use copy-on-write for read-heavy workloads with few updates, and merge-on-read for write-heavy workloads, with regular compaction to avoid read slowdown. Let's talk about partitioning. It splits a table into separate file groups based on column values. Iceberg supports transforms like year, month, day, hour, bucket, and truncate. The key advantage is hidden partitioning. You define a column plus transform, and the engine handles everything automatically while users just write normal filters. A good rule of thumb is to keep partition sizes between 100 megabytes and 1 gigabyte. Too many small partitions create small files, while too few reduce pruning efficiency. Another powerful feature is partition evolution. In Hive, changing partitions meant rewriting the whole table. In Iceberg, you just update metadata. New data uses the new scheme, while old data keeps the old one, and the engine handles both transparently in milliseconds. A few more optimization tricks worth knowing. Metrics collection lets you control which columns have statistics written, important for very wide tables, where tracking all columns creates too much metadata. Bloom filters help with point lookups on high cardinality columns, and randomizing file paths prevents S3 prefix throttling. Quiz time. Question 1. When would you choose Z-order over regular sorting? Choose Z-order when queries filter on different combinations of columns unpredictably. For example, sometimes by customer ID, sometimes by region, sometimes by both. Z-order provides reasonable pruning for all patterns. Regular sort would only optimize for the first sort column. Question 2. What's the fundamental trade-off between copy-on-write and merge-on-read? Copy-on-write gives you the fastest reads but the slowest writes, because entire files are rewritten for any change. Merge-on-read gives you fast writes because only small delta files are written, but reads are slower because the engine must reconcile delete files with data files at query time. Question 3. Why is partition evolution significant? Because in Hive, changing partitioning required rewriting the entire table, which is extremely expensive at petabyte scale. Iceberg makes it a metadata-only operation. New data uses the new scheme, old data keeps the old scheme, and the engine handles both. You can adapt your partitioning as query patterns change without any data movement. That's Chapter 4. Remember, compaction fixes small files, sorting improves pruning, partitioning enables skipping, and the KW versus MOR choice depends on your read-write ratio. These are the levers you pull to tune Iceberg performance.